Hi everyone, this is your math guru. In this video, I'm going to show you how to use the sine rule to solve the question. I have find the values of x and y in the diagram below, giving your answers to 3 significant places. Starting with x, I have the triangle ABC with the line BD, which is also x centimeters. In order to solve for x, I'm going to highlight the triangle I'll be using, which is my triangle BCD. If I draw a rough sketch of triangle BCD, I have that as. Then I have my C, I have my B, I have this as 4 centimeters, I have this as x centimeters, and then I have 34 degrees. I'm going to find the other angle at D. Note that we have a straight line, ADC, so to find the other angle at D, it's going to be angle D prime equals 180 degrees minus 51 degrees. And the reason being, the sum of angles on a straight line add up to 180 degrees. So therefore, the other angle at D will be 180 minus 51 degrees, which is 129 degrees. So I'm going to fit that in to the diagram. After doing that, using the sine rule, I have the side BC over the sine of the angle facing that's D, that's sine D, equals the side BD over the sine of the angle facing the side BD, that's sine C. Slotting in my values, BC, that's 4, over sine D, that's sine 129 degrees, equals the line BD, which is my x, over sine C, sine 34 degrees. If I cross multiply, as shown, what I will have is x times sine 129 degrees equals 4 times sine 34 degrees. Then I divide both sides by sine 129 degrees. Whatever you do on your left, you do on your right. I want to isolate my x. I have sine 129 divided by sine 129, that's 1. So therefore my x equals 4 sine 34 degrees divided by sine 129 degrees will give us 2.878 centimeters. Note that we've been asked to put the answers in 3 significant places. Also, if it's 3 significant, I'm going to adjust that quickly. That's 3 decimal. I'm going to take out that and then adjust accordingly. So that's 2.88 centimeters, I round up to 8 to leave that in 3 significant places. The next step is to find the value of y. So in order to find y, I'm going to use the diagram ABD as shown and drawing a rough sketch of ABD. What I'm going to have is, I know the value of x, that's 2.88 centimeters. The angle at D is 51 degrees. Then I have y, which is the angle I'm looking for, that's at A. I have the line BA, 5 centimeters, and then I have B. So I'm going to be using my sine rule again and stating that I have the side BD divided by the sine of the angle facing the side BD, that's sine Y, equals, then I have the side BA or AB divided by the sine of the angle facing the side AB, that's 51 degree. So like I did earlier, if I have 2 fractions equal to each other, I use the cross multiplication method. Cross multiplication, I'm going to rewrite that BD, that's 2.88. I'm going to fill in the values before I cross multiply. over sine y equals AB. AB is 5 over sine 51. Because I'm writing the first part as values, not as values yet, so I'm going to replace that as D. Then in the next line, I'll be able to write that as value. So cross multiplying, I have 5 times sine y equals 2,88 or 2.88 times sine 51 degrees, and dividing both sides by 5, I'm going to have sine y, because this cancels out, equals, then I have 2.88 multiplying sine 51 degrees divided by 5 will give me 0.4476. And in order to find y, I'm going to find the arc sine of 0.4476. So therefore, my y will be arc sine of 0.4476. Therefore, the value of y will be 26.59 degrees. But I'm going to change that because the question says we should leave our answers to 3 significant places. So y equals 26.6 degrees. Thanks for watching. Bye.